In this tutorial, we are going to solve a question from your tutorial sheet 5 on acid and bases. Now the question is saying, identify the Lewis acid and the Lewis base in the following reactions. Okay, so now let's define what a Lewis acid is and what a Lewis base is before we answer our question. Okay, so let's start with the Lewis acid. What is a Lewis acid? Okay, so a Lewis acid is a substance that is going to accept electrons, isn't it? So something that accepts electrons. Okay, accept electrons. That is what we call a Lewis acid. Okay, so the opposite is true for the Lewis base. So Lewis base, we are saying, it's a substance that is going to donate a pair of electrons, isn't it? So it's going to donate a pair of electrons. Okay, so it's donating a pair of electrons to a Lewis acid. So Lewis acid is the one that is going to accept those electrons. And then the Lewis base, the one that is going to be donating the electrons. Okay, so now if you look at these substances that we've been given here, let's start with the first one. So we're having hydrogen ions, okay, plus water, or plus hydroxide ions, sorry, okay, so giving us water, isn't it? So which one has donated electrons and which one has accepted electrons between hydrogen and hydroxide? Okay, so you notice that a hydrogen ion, for this to happen, means that a hydrogen ion is accepting electrons from the hydroxide ion. Okay, so one of the lone pairs of electron from the oxygen gas, from the oxygen, is going to be donated to the hydrogen there. So you end up forming water. Okay, so what we are going to have there is that the hydrogen is going to be accepting a pair of electrons from oxygen. Okay, so it means that the hydroxide is donating electrons to the hydrogen ion. So in that case, the hydrogen ion is the electron acceptor. So in that case, going to be a Lewis acid. Okay, so it's a Lewis acid. Then for the hydroxide, so we are saying we are donating the lone pairs of electrons, one of the lone pairs of electrons from the oxygen there. So if you are to write the structure for hydroxide, it's going to look like this, isn't it? So this oxygen is having lone pairs of electrons. Okay, that's where even this negative charge is coming from. So it's going to donate one of the lone pairs of electrons to the hydrogen there. So what we end up having is water. Okay, so here in that case, the OH is the electron donor. So in that case, it's the Lewis base. Okay, so we are saying this here is the Lewis acid, the hydrogen, and then the Lewis base in that case is going to be the hydroxide. Okay, so let's go to the next one. So the next one is, so we're having a chlorine, okay, minus. So a chlorine minus means that it's having lone pairs of electrons, isn't it? So we have lone pairs of electrons like that. Okay, so having lone pairs of electrons. Now we have B, which is bonded to Cl3. Okay, Cl, Cl, sorry, so not Cl3. So we have Cl there, and then Cl there. So this bromine can easily accept electron for us to form B, Cl4 there. So it means that one of the lone pairs of electrons from the chlorine is going to be donated to the boron atom there. So it means that this guy is accepting electrons. So this one is accepting electrons, isn't it? And then this guy, the chlorine ion, is donating electrons in this case, isn't it? So in that case, the one that is donating is this guy. So we are saying the chlorine is going to be the Lewis base, the one that is donating electrons, right? And then the boron atom there, so we get the entire molecule, which is B Cl3. In that case, going to be the Lewis acid, because it's the one that is accepting electron. Okay, so let's do the last one. So we're having potassium and water. Okay, so if you look at water, so we have this potassium, and then if you look at the water molecule, hydrogen there, hydrogen there. So it's having two lone pairs of electrons, isn't it? So it's the one that is going to donate one of the lone pairs of electron to potassium, isn't it? So you notice that what you are going to remain with is this oxygen. So remember, electrons are negative, so they are getting attracted to the positive there. So that's why we are easy donating these electrons to the positive charge potassium ion there to form K um, um, H2O there, right? Okay, so means that the water molecule, the H2O, is actually the one donating electrons. So it's the Lewis base in this case. Okay, so having the water molecule being the Lewis base. Okay, then for the potassium ion, it's the one that is accepting electrons, so it's going to be Lewis acid in that case. Okay, so that's what we are having. Okay, so that's all for this question. Now, if you want to access the full video solution for the entire toy sheet 5, okay, so let me just share it. Okay. Okay, so this is our toy sheet 5 that we are having there. Okay, so you can see all these questions that are there. Okay, so you have these follow-up questions. So if you want to access the full video solution for the questions on toy sheet 5, you can access them on our website. So you just search discretelearninginstitute.com. If you are using an iPhone. For an Android users, you can download our app on Play Store. Okay, so just search Discrete Learning Institute app. It's going to show you there. Okay, once you download our app or once you access our website, you are going to see courses that are available. So you subscribe to the course of your choice. So for example, if you subscribe to chemistry, you should be able to enter in the folder for chemistry. Once you enter there, you notice that you have a folder that is going to be written general chemistry. So you go in the folder written general chemistry. Once you go there, you have a folder written toy sheet and assessment. Okay, so go in that folder written toy sheet and assessment. Then you pick your university, UNAS, and you pick your semester 2. Also, there are intakes there, so you go for 2026 January intake. Then you see the tutorial sheets that are there. Okay, so tutorial sheet 5 there for acid-base equilibrium. You can just go in that folder, then you see the full video solution for the tutorial sheet that we are from solving. Thank you so much.